Welcome to another episode of Fort Bend Mathematics Tutoring. Take a moment to soothe your nerves. Remember, these is just numbers. They can't hurt nobody.
Hello, this is Mr. Witt with Fort Bend Tutoring, and today's tutorial is about solving natural logarithmic equations. When we're dealing with natural logs, it's important to know the natural log of x, and this is the way you would normally see it here on the left, is equivalent to a log with a base of e of x. So these two notations are equivalent to one another. You should also know that the logarithmic form, this natural log of x equals to y, can be written in exponential form in the form of e to the y is equivalent to x. So once again, you can convert back and forth between your natural log notation and your exponential notation as you see displayed right here. All right, so knowing the conversions, knowing that the natural log of x is equivalent to the log base e of x, now let's go ahead and look at some problems. How do you solve it? Let's take a look at it. In problem number 1, we have 3 times the natural log of x is equivalent to 9. The first thing you would want to do is always isolate that natural logarithm if you can. So what I'll be doing here is I'm going to divide both sides by 3. That cancels out. I can bring down the natural log of x is equivalent to 3. From here, we can convert this into exponential notation and write it as e to the third power equals to x, knowing that e, ladies and gentlemen, is a constant. It's approximately 2.71. So e is a constant, and you can just simply leave your answer that way, unless otherwise instructed by the problem or by your teacher. E to the third power is a-okay as a solution, and this is your result, ladies and gentlemen. There you go. That's how you do it. That's one way to solve that problem. You know what? Now that I'm thinking about it, there's a couple of other ways to attack the problem. So you know what? I'm going to go ahead and show you. Let's say, once again, that we have the problem 3 times the natural log of x equals to 9. Well, one rule that you should know from your logarithmic properties is that anytime you have a coefficient in front of your logarithm, you can go ahead and make that an exponent. So I could rewrite this as the natural log of x to the third power equals to 9. Once I have this, ladies and gentlemen, you can also go ahead and exponentialize this. That means, knowing that the base of the natural log is e, I can raise each side of the equal sign to have a base of e. So this becomes e to the natural log of x cubed equals to e to the 9th power. From here, what happens is the e and the natural log will cancel out. I'll bring down this is equivalent to e to the 9th power. From there, I'll have the cube root of x cubed is equal to the cube root of e to the 9th power. Simplifying this, ladies and gentlemen, your cube root and cube will cancel out to leave you with a variable x here. And taking the cube root of e to the 9th power, you would just divide the exponent. So 9 divided by 3 is 3. And that leaves you with e to the third power once again. So either one of these methods will work, ladies and gentlemen. And it appears as though the first way I gave you was the fastest way to do it. All right, so there you go. Keep in mind, ladies and gentlemen, that the domain for this natural log, as well as for any logarithm for that matter, is x has to be greater than 0. X has to be greater than 0. So anything above 0 and beyond is okay. So my answer here, e to the third power, I would be taking the natural log of e to the third power, which is going to be a value larger than 0. Remember, I told you that the constant e is approximately 2.71. So that's going to play out just fine when we cube it. All right, so keep that in mind, ladies and gentlemen. Let's look at our next problem, problem number 2. In problem number 2, I have the natural log of the quantity 2x is equivalent to 5. So what I'll do in this problem, ladies and gentlemen, is I'm going to go ahead and exponentialize this problem, meaning that I'm going to place a base of e on both sides of the equal sign and make the left and right parts of my equation exponents. So it starts off looking just like this. Using your logarithmic properties, ladies and gentlemen, the e and the natural log here will cancel out to leave me with a quantity of 2x, which is equal to e to the 5th power, like so. Then, solving for x, I'll be dividing both sides by 2. So dividing both sides by 2, I now have a result that reads x is equivalent to e to the 5th power divided by 2. Or you could even write it as 1/2 e to the 5th power. Either way is fine, ladies and gentlemen, and that's your answer. We're not going to violate the domain because the value of e to the 5th power is a positive number, so we're good to go as far as the domain is concerned in the solution. In other words, this is not an extraneous solution, meaning it can be used in the original equation. It doesn't violate the domain at all. It does not make this undefined. All right, let's continue on. Problem example 3, ladies and gentlemen. In example 3, we'll be using the logarithmic property that states that anytime you have the same base with an addition sign here, you can change this into multiplication. So I can rewrite this equation as the natural log of x times x squared equals to 3. And better yet, we know that x times x squared is simply x cubed, right? So this becomes the natural log of x cubed equals to 3. From there, I'll once again exponentialize the problem. So I'll have e to the natural log of x cubed is equivalent to e to the 3rd power. From here, once again, anytime you have this natural log and e right next to one another, they'll cancel out. So you'll be bringing down x to the 3rd power is equivalent to e to the 3rd power. Well, ladies and gentlemen, since my exponents are the same here, I know that once I take the cube root of both sides, and I'll just show that step for you here, I'll end up with a value of x that's equivalent to e. That's right. See, what happens is the cube root and the cube will cancel out to give me x, and the same thing applies to the right side. So my answer here is e. Done and done, ladies and gentlemen. That's it. All right, so keep in mind what we did at the beginning is because we had the same base, that same natural log, and I have an addition sign, I can bind that as a product. So I rewrote it as the natural log of x times x squared, which turned out to be x to the 3rd power, and then we exponentialized the problem, and after taking the cube root of both sides, we end up with a value of x equals to e. This does not violate our domain, ladies and gentlemen, because notice that when taking the natural log of e is equivalent to 2.71. All right, so there you go. All right, that's problem number 3, ladies and gentlemen. Let's move on to the next problem. All right, here in problem number 4, we have this problem. We have the natural log of e to the natural log of x minus the natural log of x minus 3 equals to the natural log of 2. So what we can do is the following, ladies and gentlemen. We can immediately go ahead and cancel out this natural log in e. Okay, that'll cancel out. So anytime that natural log is in this format next to the base of e, they'll cancel every single time. So I'll be bringing down this exponent of natural log of x minus the natural log of x minus 3 is equivalent to the natural log of 2, just like that. Since I have the same base here and subtraction on the left side of my equal sign, I can convert this into a quotient. That's right, I can write it as a fraction. So this becomes the natural log of x over x minus 3 is equivalent to the natural log of 2. Because I have the exact same logarithm on either side of the equal sign, I have a natural log here, I have a natural log there, it's a 1-to-1 ratio. If that's the case, if that's ever the case, go ahead and cancel out those natural logs. Yeah, you can just cancel them out, just like that. From there, I'm going to rewrite this as a proportion. I'm going to say that I have x over x minus 3 is equivalent to 2 over 1, just like that. Okay. From there, ladies and gentlemen, I'll use the extremes means method, aka cross multiply. All right, and remember, you can only cross multiply when there's a fraction equal to a fraction. So 1 times x is x, and then I have 2 times x minus 3, which is 2 times the quantity of x minus 3. All right, I'm going to then distribute, so I got my arrows popping, just like that, ladies and gentlemen. Love the distributive property. So I'm bringing down x, which equals to 2x minus 6. Then I'll go ahead and subtract 2x to both sides, just like so. And you'll end up with a negative x, which equals to negative 6. Dividing both sides by negative 1, you got it. X will have to equal to positive 6. Now let's go ahead and see if we're violating any domain issues. So I know I can't take the logarithm of, or natural log for that matter, a negative number or 0 for that matter. So here I'll be plugging in 6 here. That looks good to me. 6 minus 3 is 3. That's still a positive number, so we're good there as well. So ladies and gentlemen, that means that 6 is our answer. And here comes your red box, because I love putting a red box around my answer. All right, there it is, ladies and gentlemen. Done and done. The red box wins once again. Okay, next problem. We have problem example 5. In example 5, I have the natural log of 5 minus x minus the natural log of negative 3 minus x equals to the natural log of 1 minus 8x. Well, a lot of natural logs, right? Well, on the left side of the equal sign, notice that I have these two natural logs and this minus sign. Well, just like in the previous problem, we can go ahead and write this as one fraction, a quotient. So I'll end up with the natural log of 5 minus x over negative 3 minus x is equivalent to the natural log of 1 minus 8x. So this is my initial setup. Once I have the exact same natural log on either side of my equal sign here, on both sides, we can go ahead and cancel out the natural log. Goodbye. All right. From there, I'll once again write this as a proportion. So I'll be rewriting this as 5 minus x over negative 3 minus x is equivalent to 1 minus 8x all over 1, just like that. Then I'll be distributing here, I'll be cross multiplying, and you'll have 5 minus x equals to the quantity of negative 3 minus x times 1 minus 8x, just like so. On the right side, I'll be multiplying this out. So I'm rewriting this. This is going to be 5 minus x equals to, distributing here, I have negative 3 times 1 is negative 3. I have negative 3 times negative 8x is a positive 24x. I also have negative x times 1 is negative x. We have negative x times negative 8x. That's going to give me a positive 8x squared. Yeah. After that, I'm going to be combining my like terms on the right side of the equal sign, ladies and gentlemen. I'll have 5 minus x is equivalent to 8x squared plus 23x minus 3. That's after I combine that positive 24 and that negative x there. From here, ladies and gentlemen, I'll be setting the equation equal to 0. So I'm going to subtract 5 to both sides of the equal sign, and if you'll permit, I'll go ahead and add x to both sides as well, as we're running out of space. So the left side all cancels out. So what I'll do is I'll be bringing down 8x squared plus 24x minus 8 equals 0. Then what we'll do from here is we'll go ahead and divide everything by 8. That's right, we can simplify this entire equation by 8. All right, I love to simplify if I can. So you'll end up with a response that is x squared plus 3x minus 1 equals 0. Okay, from here, let's go ahead and take this equation and work it out a bit further. All right, so let's see what we got here. Let's copy that and get to traveling to a new page. Okay, so at the top of the page here, I have my quadratic equation. Well, ladies and gentlemen, this is definitely not a factorable quadratic equation. So what we will do instead is we can use the quadratic formula. So I know that my a value is 1, my b value is 3, and my c value is negative 1. From here, we'll use the quadratic formula, which is x equals to negative b plus or minus the square root of b squared minus 4ac all over 2a. Plugging in my values, we'll have the following. We'll have a negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 1 all over 2 times 1. Ladies and gentlemen, this gives me negative 3 plus or minus the square root of 9 plus 4 all over 2. Once I have this, I now have a negative 3 plus or minus the square root of 13 all over 2. So that means that I have potentially two answers, ladies and gentlemen. I potentially could have a result that is negative 3. Let me go ahead and write it out for you. It could be negative 3 minus the square root of 13 all over 2. Or it could be negative 3 plus the square root of 13 all over 2. Well, one thing's for certain, ladies and gentlemen, and that is that the square root of 13 is going to be a value larger than 3. We know this because the square root of 9 is 3. So therefore, the square root of 13 would have to be between 3 and 4, being as though the square root of 16 is 4. All right? So with this negative 3 and approximately another negative 3 or 4, you're going to end up with a negative value as a result here. Remember, in our original formula, we have to ensure that we're not violating the domain for a logarithm. So reviewing our results here, ladies and gentlemen, notice that this value here will be negative, whereas this value to the right will be positive. Well, because of our original equation, ladies and gentlemen, we need to have a negative value as a result. The reason for that is because in each of our parentheses there, it required a negative value to ensure that you would end up with a positive result. So let's take a look at what I'm talking about now. All right. Notice here that it's asking me for the opposite of the value of x. So if I have a negative result, we'll end up with a positive value inside of this set of parentheses here. We already know that our value of x is going to be larger than 3 as a value. So taking the opposite of that negative is going to give me, once again, a positive result overall here. And also in this last set of parentheses, it'll be 1 minus 8 times a negative value will give you a positive result, because the negative times a negative will give you a positive. So it'll only be our negative value that'll be a solution to this equation. The positive value won't work because when plugged into these parentheses, you'll end up taking the natural log of a negative value, and you can't have that. That's not in the domain. So that being the case, your only solution to this equation is going to be the negative 3 minus the square root of 13 all over 2. This is going to be our value here, and this value will be extraneous, ladies and gentlemen. This value is going to be extraneous. So here we just end up with one solution, whereas this solution, although we solved for it algebraically, it doesn't work in the original equation. It gives us an undefined result. All right, let's move on to problem number 6. All right, ladies and gentlemen, in problem number 6, we have the natural log of 5 plus 4x minus the natural log of 3 plus x equals to the natural log of 3. Here, once again, I notice that I have those natural logs there with a minus sign, and that means that I can go ahead and change this into a quotient. So this is rewritten as the natural log of 5 plus 4x all over 3 plus x, which equals to the natural log of 3, just like that. The natural logs will once again cancel out. I'll rewrite this as a proportion. It'll be 5 plus 4x over 3 plus x, which now equals to 3 over 1. Then distribute. Go ahead and cross multiply. So we'll have 1 times 5 plus 4x, which is 5 plus 4x, and we'll have 3 times the quantity of 3 plus x. Going ahead and distributing on the right side, I got my arrows popping. So I have 5 plus 4x equals to 9 plus 3x. From there, you're going to go ahead and solve for the equation, solve for your variable. You're going to subtract 3x to both sides of the equal sign, and if you'll once again permit me to do 2 steps in one, I will go ahead and cancel out the 5's on the left and cancel out the 3x's on the right to get a result of x equals to positive 4. So the question is, does 4 violate the domain for a logarithm? Let's see. Plugging in 4 here, that's going to give me a positive value, so that's fine. Plugging in 4 here is a positive value, so we're good to go, ladies and gentlemen. That means that x equals to 4 is the solution. No extraneous solutions here. 4 is the answer. Got a red box around it. All right. Let's move on. Problem number 7. In problem number 7, ladies and gentlemen, we have the natural log of e to the x minus 2 times the natural log of e equals to the natural log of e to the 4th power. As I told you before, ladies and gentlemen, anytime you have the natural log and e right next to one another, they'll just cancel out. So that means that I can just bring down an x from this term. I also informed you that anytime you have a coefficient in front of the natural log, it becomes an exponent. So this is just simply a negative natural log of e to the 2nd power here. Then this equals to this natural log and e will cancel out, so that'll just be 4. So this is what I have thus far, ladies and gentlemen, just like that. What we can do from here, ladies and gentlemen, is still recognize that I have that natural log and e right next to one another, right? So that cancels out. So I now have x minus 2 equals to 4, and then by adding 2 to both sides, you'll end up with x equals to 6. So you want to see if this is going to be permissible, right? You want to see if it actually will work. So plugging x in, ladies and gentlemen, this is just e to the 6th power, and that's fine. It doesn't violate any domains. The domain for this exponential function e to the x is negative infinity to positive infinity. You can put anything right there. So that means 6 is the answer. Done and done, ladies and gentlemen. All right, so walking back through problem number 7, what happened? We ended up canceling out the natural log in e to bring down the exponent x. I made the coefficient of 2 an exponent, so I rewrote it as natural log of e to the second power. Once again, that natural log in e canceled out. On the right side, the natural log in e canceled out, so we just ended up with x minus 2 equals to 4 and solved for x. And that was the end of the problem. Okay, so what do we have next? We have problem number 8. In problem number 8, I have the natural log of e to the x minus the natural log of e to the third power equals to the natural log of e to the third power. Well, ladies and gentlemen, all these natural logs and e's, we're just going to cancel out. So all that's gone. So you can just write this as x minus 3 equals to 3. Go ahead and add 3 to both sides. Once again, we don't have to worry about our solution here violating the domain because the exponential function e to the x has an infinite domain. So that means that 6 is just fine, ladies and gentlemen. It's not violating anything. That's going to be our answer. All right, x equals 6. That's problem number 8, and that also completes our video today for solving natural logarithmic equations. I hope it was fun for you because it was definitely fun for me. Please go ahead and rate, comment, and subscribe, ladies and gentlemen, and if you're able, please donate. This is Mr. Witt with Fort Bend Tutoring. Peace.
We certainly hope you enjoyed today's mathematics presentations. Did you learn anything? Do you need to review your notes? Take a deep breath and congratulate yourself. I am learning mathematics.